have to muscle up a little bit. And if you're struggling, are you going to the STEM center? Are you seeking out our tutor, Sativa? Are you coming to office hours? You know, is the first time you're seeing this when we do stuff in class and then you call it good and you're just going to take care of homework when, right, you know, the night before it's due? Or, I mean, I don't know. I mean, I don't know you guys as individuals. I'm not going to make any assumptions, but you're never going to get surprises from me. You're going to always know what to expect, which is not going to happen in college most of the time. But I've been in your shoes. I have been in your shoes. So that's just how I teach. Now, that being said, let's see when we get back, see if we can fix some of these mistakes. Francisco, good morning. Yeah. Right there. Los Rios. Conjugates. Alma, how are you? Jasmine. Marcelino. David, Marcia. David. Kelsey. Brian, finance. Going back. Take a look. So some of the biggest issues. Always simplify, reduce final answers to lowest terms. That's not just like a rule, that's actually going to be beneficial. I scratch my ear. That is, it's going to help if you reduce to lowest term as you work these things out. Watch. Calculate the slope. So, step one, you got to find the slope. We're not given the slope, so let's find it. Slope is equal to 1y minus the other y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't matter which y you start with. You can start with the -3 or the 5. It doesn't matter. I'm just going to pick the 5. So my slope is equal to that 5 minus, and it's a parentheses -3 over, if I start with that 5, I got to start the denominator with this x -6 minus this 6, which is a positive 6 minus 6. That becomes 5 plus 3. And this down here is a -6 minus 6. That's not 0. That's -12. That gives us positive 8 over -12. A positive over a negative is going to be a negative. Simplify. That's 4 times 2 over 4 times 3. The slope is -2/3. -2/3. Alyssa Rios. -2/3. It was about a handful. They got 0 down here. which, okay, I can see the, okay, 6 and -6, you get to 0. I see, I get it. So let's nip, you know, do you know who Barney Fife is? Andy Griffith Show, we have Andy the sheriff, Barney Fife was the deputy, and Barney goes, you got to nip it right in the butt. That means cut it out. Take your time. Don't make the little arithmetic mistakes. Sometimes, you know, sometimes when I get so brain dead, I just check it on my calculator. I just punch it in, just if I'm not sure. Okay. But even if you wrote, some got 8 over 0 or -8 over 0, put 8. That's another big mistake. We went over, if you get a 0 divided by a number, 0 divided by any number except 0, that's a 0. If you get a number and you divide by 0, a number over 0, then that's undefined. Undefined, it's not 8. That would be undefined. What that means is, the reason why you get 0 is because one x minus the other x, the two x's have to be the same x. That's the only way you make a 0 is because you take one thing and you subtract exactly the same thing from it. These two x's are not the same thing. So there's absolutely no way you can get 0 in the denominator. Because if you got 0 in the denominator, the slope's undefined. If the slope's undefined, it's vertical. In order to be vertical, x's have to be the same. They're not. So right there, it's telling you, stop. Stop. Yes.
This is kind of related, but so on my test, I got all the way to -203, but I kept the denominator as negative rather than just the entire thing as that. So when I were to write that out, would it just be a good mindset to always be like, oh, it's the entire thing is negative rather than just...
So here's the deal. -2 over +3. A negative divided by a positive is a -2/3. But that's also a positive divided by a negative would be a -2/3. So technically, they're all the same thing. They're all the same thing. So I don't care where you put the negative, as long as it's only one negative. Now, again, another, not mistake, but another problem. Some of you, your handwriting is so unhelpful. Not talking about me, I'm talking about for you. You write that negative and you lose it because it's either too small, it's not indistinguishable. You write it close to the equal, so you think it's part of the equals. You write it next to the fraction bar, you think it's part of the fraction bar. You wrote the negative, but then when you did the rest of the work, you didn't see that there was negative there. You lost it in the process of doing the problem. So if you clean up your work, you'll make sure you won't lose it. Okay. And I'll be able to, partial credit if something else goes wrong somewhere else, at least it's not because of that. Something that can be avoided. So slope -2/3. Step 1, find the slope, down the slope. Step 2, is it a special case? No, because the slope is not 0, it's not undefined. So step 3, I write down, trying to figure out this puzzle, and there's the hint. So I write down y equals mx plus b. And my job is to figure out the m and the b, find those pieces, and then write the equation of the line. So that's step 3. Step 4, I plug in the slope. I plug in the m. That's the only thing I know right now. So I got y equals -2/3 times x. I don't know what b is. Gotta solve for b. So to solve for b, we plug something in for x and y. we have two possible choices, because that's an X and Y that's on the line, and here's another one that's on the line. So pick one of them and use that X and that Y, and then you can solve for the Y-intercept, solve for the B. It doesn't matter which of the ordered pairs you pick, just got to choose one of them. So I'll just choose the first one. So that means if I'm going to use 6, -3, I'm plugging 6 in for the X. I'm going to let the X equal to 6. And going in for Y, the Y is -3. So -3 is equal to -2/3 times X is 6, and then plus the B. Now, simplify. Because I reduce this, look how nice this works out. I got -3 equals a negative times positive, negative. 3 goes into 6 2 times. 2 times 2, that's -4. Plus B. If I leave it as 8/12, then 8/12 times 6, sure, I'm going to have fractions. And some of you worked with all those fractions. And some of you tried, and some of you might have gotten there. But it didn't need to happen because it reduced. Okay? It's got, and you got, your final answer's got to be in simplified form anyway. To solve for B, we got 4 to both sides. -3 plus 4 is 1. The Y-intercept is 1. Finish the problem. Y equals -2/3 times X plus 1. Easiest way to see if it's right. If I came up with the right equation, then this ordered pair should make this equation true. So if I use -6 for the X and 5 for the Y, it should work out and be true. So -6 for X and Y is a 5. So 5 equals -2/3. X is -6, so times -6, and then add 1. And 5 equals negative times a negative is going to be a positive. 3 goes into 6 2 times. So basically -2 times negative, positive 4 plus 1. 5 does equal 5. When I plug in the second order pair into the equation that I hope works, it works in that equation, which means I have the correct equation for the line. Okay. Any other questions about the first one? Because you're going to see something like this, not just one of them, but you're going to see all sorts of different, right, the equation of a line. This is just section 1.1. I'm sorry, 1.2. In addition to other stuff. Yeah.
So on the instructions and then what you told me to do as a correction. So it says to find the self-intercept form, which I had done, but I guess I didn't do it far enough because you just felt this now to plug in whatever order pair was given to us.
No, this part over here?
Yeah.
No,
I didn't do that.
No, I'm telling you, how can you check before you walk out of the door? If you have the time and you want, you're one of those that is kind of like, I'm not sure. How can you check for yourself? Not for me. You don't have to show me this. Right here, the blue to the black right here.
Yeah.
That's just, did I get the right answer for yourself? So you can see if you came up with the right equation. All you have to do is plug in the other ordered pair, and if it worked in the equation you made, you have the right answer. That's all.
Well, it just says I'm here to solve for B, and
so you never solved for B.
I never solved for B. That's why I was.
Oh, okay. Then that, yeah, you've got to come up Y equals MX plus B.
I just got B.
Right.
I just got Y equals 2/3 of.
And it says right here, write the equation in slope intercept form. Y equals MX plus B.
I just thought when it said like writing something or something for me, that it would just stop when you wrote like y equals -2 x. So I never solved it. I just wrote it like that.
Right, but when the warm up that we did at the beginning of class, I figured out B and everything.
I was in there. So,
Oh, at the beginning of class?
you know,
Okay.
I had like.
Gotcha. Okay. But in the homework that I'd gone over, the examples that I'd shown, the steps that I had written, step by step, okay, it's all there. Are there any other questions about this? Because unless you solve for the B, you don't have the equation of y.
I didn't. I thought it was just like write it as is. So
All you did was find slope, so we would just thought, what's the slope? Right. All right, second one, parallel, perpendicular, or neither. So you have to compare slopes. If the slopes are equal, you've got parallel lines. If the slopes are opposite and reciprocal, you have perpendicular lines. And if the slopes are neither one of those, then it's neither. To find the slope, solve for y. Because the slope is the coefficient of x. So we have to solve for y. So we can get this, the y by itself. We have to put this -35x on the right-hand side. You're going to add 35x to both sides. So now you have 25y equals 35x and then a positive +5. And then to get y by itself, divide everybody by 25. Everybody gets divided by 25. And again, didn't simplify. Reduce. You're trying to compare a 35 over 25 to something else. Y equals 35 and 25 have a common factor 5. This is 5 times 7 over 5 times 5x. And this is 1 times 5 over 5 times 5. So y equals, the 5 reduced, 7/5 times x plus 1/5. So the slope of the first line, line sub 1, L sub what? The first slope is 7 over 5. And then we do the second slope. We want y by itself. So now it's all mixed up. We don't have ax plus by equals c. You got x over here, 5 y's on the right side, you got 5 over there. I saw some people go like this. 7x, subtract 7x. And then I saw this. I saw that 5y equals -7x plus 5. Absolutely false. Totally, I guess I saw that, I go, all right, what's their phone number? I need to call them and have an intervention right now. Because you subtracted 7x from both sides. How did the 5y end up on the left side? 5y is on the right. How did 5y, now how's it on the left of the equals? To get on the left of the equals, you would have to actually do something to the 5y. You didn't. You cannot just make stuff up. Okay? Can't. Equations are equal because they're balanced. Whatever you do to one side, you got to do the other side. Nice and just, okay? So if anything, this is 0 equals 5y minus 7x plus 5. If anything. Because that's what you have on the left side. 7x minus 7x is 0. Okay. Now, you could have done it that way, but watch how you could have done it. And I gave you one like this in the warm-ups. I gave you 3 possible, because I wanted to show you an example of one that comes out parallel, one that comes out perpendicular, one that's neither at the beginning of the class. So I gave you one where the y and something was on the right and the x was on the left. So I told you it's okay to get mx plus b equal to y, get y on the right, and then if that still bugs you, just flip them around. Y equals mx plus b, and then figure out your slope. Okay, perfectly fine to do that. So if I'm going to get y by itself, I have to subtract 5 from both sides. On the left side, I have 7x minus 5 equal to, on the right side, all I have is 5y. To get y by itself, divide by 5. Everybody gets divided by 5. So we now have 7 over 5x minus 505 is 1 equals y. And again, if that, because it's written backwards, if that bothers you, then trade places. The symmetric property of equality says if A equals B, then B is equal to A. You can switch around. So y would equal 7 over 5x minus 1, which means the slope of line 2 is 7 over 5. So line 1, the slope is 7 over 5. Line 2, the slope is 7 over 5. So the 2 lines, line 1 and line 2. Line 1 is parallel to line 2 because the slopes are equal. And you can say this basically because slope of line 1 is equal to the slope of line 2. Or no, I don't think you remember the first thing. No, there's no retakes, there's no makeup quizzes, there's not. But at the end of the semester, I dropped your 2 lowest quiz scores. So when a bad day happens, and then you. Does anybody watch Ted Lasso? All right. What animal has the shortest memory? Remember that? A goldfish. Yeah, one of his players went out there and made a mistake, and so he's thinking about dwelling on it, and he says, goldfish, 10 second memory. Dory. Okay, you had a bad one, you got to put it behind you and move on, make it better. Okay, move on, make it better. So that's what I'm here for. And I've gone so slow, we've only covered 2 and like a third of a section. And so I am gonna have to, put it into second gear. And we're gonna have to get this truck moving. And so I don't want to ever lose it, ever. So that means I need you, if you need help, I'm here. STEM Center, there. Okay, Sativa, it's there. The flyer is posted. Don't wait. Use people, use each other. Study groups. Okay. All right. Any questions?
Actually, I did not the first one because I was kind of way off catching up. My first response for B is -3 equals 2. There's a motion on the present user.
Right here.
Yeah, where the red circle is.
Right here?
Yes, slow this down.
That's a B.
That's a 6.
No.
And then that's a parentheses. No, we're trying to solve for B. Yeah, right there. Yeah.
Okay, so it was
-2.
-2/3, my slope. And then I plugged 6 in times 6. I plugged in 6 for the x. So 3 went into 6 2 times. And so in the numerator, -2 times 2 gave me that -4. And then the denominator is a 1. So because 3 goes into 3 once down below. So I end up with 4/1, which is just -4. And now you don't have a fraction. Yeah. Okay. We left off working on our functions, notation. Function is a set of ordered pairs, domains and ranges, x's and y's. It's a special relation. Any set of ordered pairs is always a relation. You got an x, you got a y, you got a relation. Special relations are when the x's do not show up more than once in any of those ordered pairs. X cannot repeat. Y can repeat, but X can't. If X repeats in any of the ordered pairs, not a function, just a relation. Just a relation. If X is unique in all of the points, that's a function. So let's take a look at where we left off. Testing out greatly, talking about function notations, about Euler, substitution. I'm going to show you some of those. Okay. And I'll go that later. I'm going to switch around a little bit, and I'm going to give you all of this information as we go over examples from the homework. So everything that we do right now is going to be done as an example from the homework itself. But I do want to pick up at least one place. I did stop us right here at example number 3 from the text. And it's just substitution. And I want to do this before we move on, before we go to the homework examples. So they give us a function g of x is equal to negative x squared, and then plus 4 times x, plus 1. And it wants us, I'm going to throw in an extra one. It says, evaluate, find, A, what is g of a 2? And then I'm going to change this. I'm going to put in an extra one here. So what is a sub 2? Find g of negative 4. And then B, what is g of t? And then last but not least, we'll do C. What is g of x plus 2? Okay. So it's about substitution. I don't give a flying turd about how good you are. try to just substitute, then simplify. Substitute, then simplify. Okay, yeah. Mr. Caveman up here with his ancient references. Has anybody ever seen the movie Top Gun?
Yeah. Tom Cruise.
Tom Cruise, yeah, Anthony Edwards. There used to be an actress by the name of Meg Ryan who doesn't exist anymore. When Harry Met Sally and Who's Got Mail and all this other stuff. She was the darling, and for almost she's gone. But anyway, Tom Cruise was told by his commander, you're writing check, your ego's writing checks your body can't cash. Don't let what you think you can do write checks that what you're doing is not cashing, not backing it up. In other words, substitute, write it out, then simplify. Don't try to plug it in and then in your head do the answer. If I looked up here and I looked at this and I said, all right, G of 2 is equal to 5. What do you mean you don't get it? What's the matter with you guys? Come on. Can't everybody do it? I'm not sure. Like this. Sorry. Anyway, you need to, first of all, if you get it wrong, there's no partial credit for me to give you, this is going to work. Number 2, substitute G of 2 equals. Is that negative being squared? No. The x is being squared, the negative is just hanging out in front. So when I plug this in, there's a negative, and then the 2 is what's actually being squared. And it looks like this. There's a negative, and then your 2 is squared. But here's what I know students see. Oh, negative 2 squared, that's positive 4. No, it's not. This is not negative 2 squared. This is not negative 2 squared. That's like a minus a 2 squared. Or it's a negative and then 2 squared. If you want negative 2 to the second power, it has to be like this, negative 2 to the second power. Because this right here is a negative and then a 2 times 2. That's negative 4. This right here is negative 2 times negative 2. That's positive 4. There's a huge difference. Okay? Difference of about 8 from negative 4 to 4. Okay? So when you plug it in and just show the substitution, it's negative and then the 2 gets squared and then plus 4 times 2. And then a plus 1.
When do you know the other parentheses for this?
You know what? If I substitute something, it never hurts to put parentheses. It really doesn't. Especially if I have to square it or multiply it with something or whatever. If it's negative, definitely. Negative. Why is something negative? Because they're sad, they're upset, they're angry. You know what negatives mean? They need a hug. Negatives mean parentheses. Definitely with negatives. Definitely with negatives. But it doesn't hurt. It's not going to hurt anything if you put it on a positive. But you just make sure you don't go, oh, it's inside because that negative is not in there. Okay. So it would be a negative and then square root of positive 2 and keep the negative out front. Yeah. Right here, the parentheses, because it's 4 times the x. I have seen students go put the 4 and the 2 just without anything. The next step, they make up the next step and they go 4 plus 2 is 6. Because they didn't put that 2 They didn't put times next to it. They didn't put anything. If you put it in a parentheses, then you know exactly what you're going to do next. Okay. So now G of 2, one step at a time. There's a negative, and then 2 to the second 4, plus 4 times 2 is 8, and then a plus 1. So from left to right, negative 4 plus 8 is positive 4 plus 1. So G of 2 is equal to a 5. Okay. What's the domain of that problem right there? The 2, the x. What did I plug in for x? I plugged in a 2. What's the range? What came out? The 5. The domain is the x value, the range is the y value. Domain is the x, the range is the y. As an ordered pair, 2 went in for x and 5 came out for y. Yes, always. If it's a function with respect to x, this is a function, and x is your variable, then the ordered pair goes, domain is what you plug in, range is what comes out. Okay, yes.
So for this problem, will it specifically tell us to write it as an ordered pair? Or is it
Exactly, it will when they want you to. Right here, they just want what does G of 2 equal. So you would stop there. I'm just showing you what else does it mean. Okay. Now we're going to plug in a negative. And again, if you just see the substitution first. So I'm replacing this x with a negative 4. So that x is going to get replaced with a negative 4. And that x right there is going to be replaced with a negative 4. So just the substitution. There's a negative right there. And then I'm replacing the x with a negative 4, and then I square it. And then we have plus 4 times. And I'm replacing this x, so times another negative 4. And then we have a plus the 1. So that G of negative 4 is equal to, there's a negative down in front, so that doesn't change. And then this negative 4 to the second power. A negative 4 times a negative 4 is a positive 16. So you have this negative in front of your positive 16, which makes it a negative 16. And then we have a positive 4 times a negative 4. Positive 4 times negative 4 is negative 16. And then we have plus 1. And then G of negative 4. From left to right, negative 16, take away 16 is negative 32 plus 1. G of negative 4 is negative 31. Okay. Question that. So, whatever you're told to replace x with, that's what you do. That is exactly what you just do as you're told. You know that G of x is negative x squared plus 4 times x and then plus 1. So what does G of t equal? Whatever goes into the G function replaces whatever x is. So whatever replaces this x right here replaces all the x's. So g of a t, if I replace this x with a t, then I replace all the x's with a t. And by the way, if you're going to use t as a variable, and we will because we like to, do things with respect to time, make your t's with a little, hook at the bottom so they don't get confused with plus signs. Okay. So negative. And then going in for x is now a t. So if I just use parentheses, it's no big deal. I'm just going to just keep up my pattern. T, and then I square it. And then plus 4 times x is now plus 4 times, but that x is now times t instead. And then you still have plus 1. So now when we simplify this, g of t is equal to. So if I replace x with a t, I get negative. Positive t to the second is just t to the second. So there's a negative and then t squared. And then 4 times t is just 4t. And then plus 1. That's all you do with it, because I don't know what t is. Okay, that's it. That's what it looks like if you plug in t. If I plugged in happy face, g of happy face, it would be negative and then happy face squared plus 4 times happy face plus 1. Because you replace the x with a happy face. And that's after you squared it is. Oh, I've had great days, and then somebody just kicks you out. If you watch Ted Lasso, he has the crappiest of days. He always has. It makes you get sick. Especially in UK type. All right. Then you see stuff like this. This is bread and butter right here. This is what happens when you move along after this class. Replace x with an x plus 2. So I'm going to write that over here. So if I plugged in 2, then all the x's became 2s. When I plugged in negative 4, all the x's, one at a time, in parentheses, wrote it out, became negative 4s. When we plugged in t, all the x's got replaced with a t. When I plugged in happy face, then all the x's became a happy face. So this time, if I substitute x plus 2 in for that x, if I replace that x with an x plus 2, then every single one of these is now going to get replaced with an x plus 2. So instead of an x, replace it with an x plus 2. So this looks like there's a negative, and then you're supposed to have x squared, but it's not x anymore. It's parentheses, x plus 2, and then you're squaring it. The x became an x plus 2 because that's what we were told to plug in. And then you have plus 4 times x, so that's now going to be plus 4. That doesn't change. But instead of an x, it's times an x plus 2. So parentheses times an x plus 2. That x is replaced with an x plus 2. And then you still have a plus 1, which doesn't change because it doesn't have any variables. Now, That's what it looks like if you just stopped and only did the substitution and didn't simplify. Of course, that's not where they're going to stop. There it comes. G of x plus 2 is equal to, there's a negative. So now I'm going to multiply that out. So times, inside, x squared plus 4x plus 4. And then I'm going to distribute this 4. So plus 4 times x, and 4 times 2 is plus 8, and then a plus 1. Go ahead. I'll wait over here. We have your question. We don't. I get the same question in every class, all the way to the highest levels I've ever taught. Where did blank come from? X squared plus 4x plus 4. I know. Not here. This right here is one of the, I'm sure math teachers you've ever had have sat there and just said in front of you, all right, everybody, when you have a plus b and you square it, the formula you have a squared plus 2ab and then plus b squared, make sure you know that. Nobody ever knows that. Why? Well, it makes your life easier if you memorize it, then you don't know it. If you actually know it, then that's great. But teachers tell you to know it or try to memorize it so they don't have to teach you. Okay? They really try to get away from trying to teach you. What students want to do is this. Hey, a plus b squared, that is a squared, and then you go square the other one. You square one, you square the other one, and then you don't have the thing in the middle. Well, if that were true, 2 plus 3 squared. If this is true, then I should get 2 squared and then 3 squared. I can just do that. What's 2 squared? 4. What's 3 squared? And 4 plus 9 is 13. But if you actually follow the order of operations and do parentheses first, what's 2 plus 3? This is 5 to the second, and 5 squared is? Are they equal? No. So this means that you can't just go, hey, a squared and b squared. You're missing something. The reason why there's something in the middle is because when you do this, it means you're doing this, a plus b times a plus b. And you have to use that 4-letter F word that you were probably told so often. FOIL. Now, I don't use FOIL. I like ceramic plastic. Maybe even some wax with it. Now they have no reusable thing to stick on there. I can never get that thing on. Tupperware. The analogy that I use is you got to make them dance. Distribution, it's multiplication, it's just distribution. There's 2 guys at the dance, there's 2 girls at the dance, or who, I don't care who, but there's 2 people here, there's 2 people on the other side of the room. You just make sure that everybody dances with everybody. 2 people from this side of the room dance with 2 people on that side of the room, but they dance one at a time. So distribution. This a times that a, that's a to the second power. This a times that b, positive and a positive, that's a times b. This a has multiplied, has been distributed, has danced with everybody in the other group. So now it is the b's turn. We distribute b to both. So this b positive times that a. Now, b times a is the same as a times b. multiplication commutative. B times A is the same as an A times B. And then the last person to dance with the last person to dance, positive B times positive B to the second. So we end up with A plus B, when you square it, the first one is squared, A squared. In the middle, you have one AB plus one more AB. One of them plus one of them, there's two of those ABs in the middle. And then at the end, you have your B squared. So what that means is over here, in the front, you have a 2 squared, and then a plus. In the middle, 2 times A times B. You multiply the A and the B together, and you double it, 2 of the A times B. So you get plus, you have 2 of this A times that B. 2 times A times B. And then we have a plus of B squared, so plus of 3 squared. So 4 plus 2 times 2 is 4, 4 times 3 is 12, plus 9. 4 plus 12 is 16 plus 9, 16 plus 9, 25. 2 plus 3 is 5, 5 squared, 25. Which way should you be doing this kind of a question? You should do it this way because order of operations. Order of operations. So the way I got this right here is it's A plus B. So it was X squared, first one squared, and then in the middle, plus 2, because there's double, twice, the A times the B, so X times the 2. So X times 2 is just a 2X. Double them, A times B. And then plus the last guy, the last term, 2 squared. So there's the X squared. 2 times 2X is 4X, and then plus 4. But you've got to practice that. If you're going to use, technically, it's just a shortcut. It's just a shortcut. You have A plus B squared is A squared plus 2AB plus B squared. If it's minus A minus B squared, it's exactly the same except the sign in the middle. It's A squared minus the 2AB in the middle and still plus B squared. And then one of the most important of all, if you have A plus B times A minus B. Special name for something that looks like this is called conjugates. They're exactly the same terms, A and an A, B and a B, but the signs are different. And if you multiply them together, you get A squared minus B squared. There's no term in the middle. Because in the middle, it's going to cancel out. If you make them dance, A times A is A squared. Positive A times negative B is a negative A times B. So when you distribute A times A is A squared. A times negative B is negative AB. And then you distribute the B. B times A, that's a positive AB. And then positive B times negative B. A positive times a negative is a negative. B times B, B squared. So there's the A squared. In the middle, negative AB and positive AB make a 0. Minus B squared. It's called the difference of 2 perfect squares. Because it's subtraction and you have 2 perfect squares. Difference of 2 perfect squares. The most important thing about that is not just being able to multiply left to right, but knowing that the formula goes right to left. Recognizing when you see this, that it factors into that. Because you also, I'm sorry, you still have to know how to factor. You have to know how to factor. If you're going to go this class and beyond. I mean, the name of the class is college algebra. How are we going to get away with algebra? Okay. So this thing now you have a negative in front of the parentheses, distribute the negative. So all those positive terms become negative terms. A negative times a positive x squared is negative x squared. A negative times a positive 4x is now a negative 4x. A negative times a positive 4 is now a negative 4. And then you still have your plus 4x and your plus, well, 8 plus 1, you can make that a 9 if you want. Those two add up to 9. And then the last thing you can do is simplify any common or like terms. So I'm looking to gather up all the x squareds. This is the only x squared in the polynomial, negative x squared. My x to the first, negative 4x and a positive 4x, they add up to 0, so they cancel out. And then negative 4 plus 9 is plus 5. And that's what it simplifies. I mean, when you look at the two possibilities, negative parentheses x plus 2 squared plus 4 times x plus 2 plus 1, or just negative x squared plus 5, which one is more simple to deal with? Okay. Yes, sir.
Do you mind going over the second step one more time? Just
absolutely, no problem. So this right here to here or here to here? This one?
Yeah, from g of x plus 2. Yeah, right there.
From here to here.
Yeah, because I didn't know how you got the.
Okay, so I use this formula to take this to make it this. Or negative, and then you got to multiply x plus 2 times x plus 2. Because knowing what's the answer to x plus 2 squared, that's not like a 3 to the second. It's not like something simple. And then distribute 4 times x, and then plus 4 times 2, distribution, and then you still have the 1. So that's where the 4x, the plus 8, and bring down the 1. So then what I did was I'm leaving the negative to distribute last, negative, and then I multiply the inside x plus 2 times x plus 2. So distribution. This x times that x is x to the second. This x times the 2 is a plus 2x. So we're done with the distribution of x. Now we distribute 2. A positive 2 times x is a plus 2x. And then a positive 2 times 2 is a positive 4. That's how I got the inside of the parentheses.
I just didn't want to see that part.
Yeah, and that's where I was going through and explaining where that formula came from, so you can know the formula and be able to use the formula. Or you can actually multiply out, FOIL it out, x plus 2 times x plus 2. Just don't forget there's a negative out in front until the last part is when I distributed the negative, and those 3 things became negative terms. And that's always your safest bet. If I had 5 times x minus 4 squared, I would square this and distribute 5 last. Because when you think of order of operations, the first thing you do is parentheses. Well, parentheses, I can't do anything with x minus 4. The second thing you do is exponents. You're supposed to raise this to the second power. The 4, the 4 you multiply. Exponents before multiplication. You cannot distribute 5 until you do this exponent, because order of operations, you have to take care of the power before you can do the multiplication. If it was 5 times 4 to the second power, you don't get to go 5 times 4 is 20 and then go 20 squared. It's not 20 squared. You have to go 4 squared, that's 16. And then 5 times 16 is 80. So you have to actually do the square before you can multiply. You would have to actually do the square before I can multiply the 5. Okay. So that's why you bring down the negative before you do the all the time, and then do the square first. Yes, sir.
Sorry. So for the last part, where you have the negative x2 minus 4x.
Negative x to the second power plus 5.
How did you like cancel out the 4x's? Or
Well, that's a negative 4x, positive 4x. They add up to? They add up to what?
0.
Yeah.
So it's just a matter of like.
So what do we have left? We have a negative x squared. That's the only x squared in the entire polynomial.
Mm-hmm.
So then I'm going to gather up all my x's, combine like terms. I have negative 4 of these x's and positive 4 of those x's. If I have $4 and then I owe her $4, that's a negative 4. So my positive 4 and the 4 that I owe her means I have no dollars left. Okay. And then a negative 4 and a positive 9 makes 5. So I think this time is very important that we kind of walk you through the 1 through 6 all. No, especially when you don't have the evens in the back. And this is about understandings. That's where the first few questions are always about when I address these. It's about the concept and the language. So a relation that assigns to each element x. So each element x from a set of inputs or blank, exactly one element y in a set of outputs or blank is called a what? So a relation that assigns to each element x from a set of inputs or the domain. From a set of inputs or the domain. Exactly one element y in a set of outputs or the range is called a what? A relation that does for every one x you get a single y is also called a function. For an equation that represents y as a function of x, y is a function of x. The blank variable is a set of all x of the domain, and the blank variable is a set of all y in the range. So now I'll give you the multiple choices, dependent and independent. Exactly. So the dependent, so who depends on who? What do you plug in? You plug in x's and out comes the y. Y depends on what x equals. Y depends on what x equals. X can be anything it wants to be. Like an independent can be anybody it wants to be. X is your independent variable. And this is the dependent variable. Y is the dependent. Can the two ordered pairs 3, 0, 3, 5 represent a function? That's just a yes or no. No, because if I plug in 3, then the y is a 0. But over here, when I plug in 3, y is a 5. X cannot repeat if it's a function. You can't have two different y's for the same x. X cannot repeat. So when I plug in 3, I get one answer for that 3 and only one answer when I plug in 3. You can't get two different answers for the 3. So 3 is enough. Now 4, to find, g of x plus 1. Oh, we just did g of x plus 2. To find g of x plus 1, what do you substitute for x in the function g of x equals 3x minus 2? What do I substitute? Means plug in. What do I plug in for the x? X plus 1. If I want to figure out what g of x plus 1 is, then I'm going to replace this x with an x plus 1. That means I replace that x now with an x plus 1. It's not asking you to do it. It's just asking you, what do you replace the x with? Well, it's asking for g of x plus 1. So you're replacing the x. Instead of an x, you're replacing it with a g of x plus 1. What do you do to it? Well, whatever goes in, you multiply by 3. So now it's 3 times instead of an x plus 1, and then a minus 2. They're not asking for this. I'm just showing you what it would look like. Okay. Domain and range. For our purposes, for everything that we technically are dealing with, there are two words that describe our domains and range. We have implied and explicit. We have explicit domain or explicit range. When something's explicit, it's like it's in your face. You are told. When something is explicitly said, explicitly written, that means you know for sure. If it's implied, it's kind of like, well, when you read these rules, it implied that you shouldn't be doing blank. Right? When it implied that you should have been prepared to do this. Okay? When it said you needed to be a student in good standing, that implies you can't have a 0.0 GPA, Blutarski. Really? No? It's not Animal House? Okay. So, implied versus explicit. The implied domains that we are going to have to be aware of, the ones we have to watch out for, things you cannot do. A function doesn't work if you have zeros in denominators. We want to avoid 0 in denominator. So the only time you got to really worry is if you have x's in denominators. If you have x's in denominators, then you might get a 0 when you plug something in. If your function doesn't have a denominator, then there's no reason you can't plug every real number into the domain. That's the domain, all real numbers, negative infinity to infinity. If it doesn't have one. So if I gave you something like, you know, f of x was equal to 5x minus 4, there's no denominator that's possible over here on this right-hand side. So there is no chance of getting a 0 in a denominator if you don't have a denominator to begin with. So the domain of something that looks like this, all real numbers, negative infinity to infinity. If I gave you f of x equaled 3 plus x over 2. Okay, that's got a denominator, but is there an x in the denominator? Yes or no? No, there's no x down here. The only thing you're going to plug x's are in the numerator. You can't have 0 down below. The denominator is always a 2. So this is perfectly fine. There's nothing that's going to ruin it. The only time you got to worry is when you have an x down here. If you've got an x down there, f of x is equal to 1 over x minus 3. Now you have a problem. You've got x in the denominator. What would cause that denominator to equal 0? What value of x can you not use? 3. If you plug in 3, f of 3 would be 1 over 3 minus 3, and that's 1 over 0, undefined. So the domain of this function is every single possible real number, except don't use 3. You cannot use 3. All real numbers except the number 3. You can use 2.99999999999999999, but don't use 3. Okay? Denominators can't be 0. And then the second thing you have to be on the lookout. Right now, the only other thing you're going to worry about is square roots, or technically even roots. Even roots, even radicals. Square roots, fourth roots, sixth roots. We are mainly going to be living in the land of real numbers, not imaginary, not complex numbers, but just the real numbers when we do our work here. The only time you need to worry about dealing with complex numbers, imaginary numbers, I, is when you are told, hey, we're using complex numbers. Then you should be on the lookout for any square root of negatives. Those would be fine. You're just using imaginary numbers. But for now, square root of a negative, not allowed. Not allowed. Square root or any kind of even root, a fourth root, a sixth root, because you can't take an even root of a negative. Square root of a negative, fourth root of a negative, sixth root of a negative, and so on. You can't do it. Yes.
Pretty much what is in square root negative.
So undefined. Undefined. Yeah, not in the domain. Not in the domain. Not a real number. So square root of -4 is not a real number.
Isn't that like a symbol for
that? For not a real number, the symbol for real number is an R basically is like 2 legs. And I guess if you're going to put not a real number, you put a bar through it. But usually we would say like this. If the domain was all real numbers, if it was all real numbers, we do this. X belongs to, that's the symbol for belongs to in mathematics. X belongs to the set of all real numbers. That's not a C domain. It's like a C with a little line through it. Belongs to the set of all real numbers. Okay. It's gravity. I belong. So right here, all they're asking is, does the domain of square root 1 plus x is -2 in that domain? Well, let's plug it in. F of x is the square root of 1 plus x. So if you plug in -2, you get the square root of 1 plus a -2. So f of -2 is the square root 1 minus 2. And that's the square root of -1, which is not a real number. So does it include? No, it doesn't include. If it asks, does it include -1? Well, if I plug in -1 instead, 1 plus -1, which is now 1 minus 1, that's the square root of 0. What's the square root of 0? 0. So f of -1 actually works. So if this were the function, yeah, -1 works because it's 1 plus x. Okay. And then the domain of a piecewise defined function, a piecewise function. A piecewise function is a function that is defined by separate pieces. It's got pieces, one piece and then another piece and then another piece, based on certain sets of numbers. Is it implied or explicitly described? So let me show you what a piecewise function looks like. We get to the piecewise right here, 41 to 45, 46. So look at 44 right there. Never mind, I can't. The function f of x is equal to the first piece. You plug it into x squared minus 4 if you're choosing x's that are less than or equal to a 0. When you are plugging in numbers that are bigger than 0, you plug it into the second piece, 1 minus 2x squared. So if I choose numbers, if I'm plugging in numbers that are basically negative or equal to 0, I plug them into the first piece. So if I want to plug in -3, I have to plug it into that first piece, not the second. If I want to plug in 0, I plug it into the first piece because I have the equals. If I want to plug in 5, well, 5 is not here, 5 is greater than 0, I plug it into the second piece. Is that implied or is it explicitly telling you what goes where? Let me emphasize that again. Is it explicitly telling you what goes where and when? It's explicit. Because it is explicitly telling you for this piece of the function, this is your domain. This is what you use for this piece. And this is what you're going to use. This is the domain for that second piece. When you have a 3-piece function, that's got 3 pieces. First piece, if you plug in numbers less than 0. The answer is 4 in between 0 and 2. For everything between 0 and 2, the answer is 4. So when you plug in a number greater than or equal to 2, the answer is x perfect square. You plug it into that piece. And that's a piecewise function. Does anybody know anything about the speed of sound? What I call Mach 1, Mach 2. Mach 1 is speed of sound, Mach 2 is twice speed of sound, Mach 3, 3 times so on. The speed of sound, how fast sound travels, depends on how much air pressure there is, atmosphere. Because sound is a wave that is propagated through the molecules in the air. You know, ice heat vibrates the air all the way to your eardrum, and it vibrates your eardrum and you hear. The less air there is, the less pressure there is, less atmosphere, sound travels more slowly. the more dense the air is, sound travels more quickly. So in order for a car to break the speed barrier on the ground, it has to travel a lot faster than a plane does up in the sky, because speed of sound is a lot faster because the air is more dense here on the ground because we have all the atmosphere above it, squishing it. But the air pressure up high is so much less. So when they first broke the speed barrier, when they first broke the speed of sound, 1947, Colonel Chuck Yeager in the X-1 Bell, he nicknamed Glamorous Lennox. Anyway, you had to fly that thing, you know, a few miles high, and it didn't take off from the ground and go up and fly. It dropped from a bomb, because you know how much fuel it would have had to have taken to get it from the ground up to there? It didn't have enough capacity to get the fuel in there to get it up in the air. It just had enough fuel to break the speed barrier. So he dropped it like a bomb, and then he hit basically the jet rockets, and he took off like a bat out. Nobody had ever broken the speed barrier before. Nobody knew what it was going to be like. Okay. You know, if you ever see the movie The Right Stuff, they explain it like you're going through a brick wall. And that's what it kind of felt like. Everything vibrates. Anyway, later on, within about 14 years, have you ever heard of the SR-71 Blackbird? One of the stealth jets. Highest flying, fastest flying jet we've ever made, that we've been told of. SR-71 flies, I believe, at Mach 3 plus. 3 times speed of sound. At about 25, 30 miles high. Minimal fuel when it takes off. And when it takes off, it leaks. All the fuel leaks. If you go up 99 and go past Atwater, there's an air base right there. They have a SR-71 that's been decommissioned at the museum. It leaks because when you're traveling that fast, air friction tightens up, you know, basically expands all the metal. And if the thing was built, you know, with the metal slats next to each other, when the heat expands it, it would have buckled and broken apart. So they built the SR-71 with just enough leeway. So when it hits the, you know, Mach 1, Mach 2, Mach 3, and the metal expands, it seals all the leaks. Now, what about the fuel? It takes off and then it comes in and gets refueled before it actually starts its surveillance work. And that's what it was used for. Okay. But the whole idea is this: the higher you go, the less air pressure there is, which means you don't have to go as fast to break the speed barrier. That's a piecewise function. Depending upon your altitude, plug in an altitude, you're going to use a different equation to calculate the speed of sound, because it was all based on air pressure and altitude. Okay? Piecewise. The domain is explicit. Something like a square root, something like a rational function, those are implied. A polynomial functions, the domain is always all real numbers. Now, a polynomial function, in case you're wondering, looks like this. Something like f of x is equal to a times x to the n plus b times x to the n minus 1 plus c times x to the n minus 2 plus blah, 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 plus all the way down to a constant, usually. But it's basically powers of x. No denominators. So no, nothing can go wrong in that function. All real numbers. Plug in anything you want. Okay. So the first question, number 7. I'm going to do number 7 and 10. In fact, I wrote down what I want to handle here. Let's put it over here. See how many we chip away at today. 1 through 6, 1 through 7, 1 through 10, 1 through 13. Now this is going to continue for Monday, or sorry, Tuesday. 16, 19, 21, 33, 39, 43, 46. I'm going to just explain what goes on 53 and 55. 57, 59, 60, 61, 62. And then you have to choose 67 or 69. And then I'm going to do number 71, and then you got to choose again. 73 or 75. And then I'll do 81, and then you got to choose one more time. Choose 83 or 85. All right. So number 7, looking at that given information, domain versus range. Now remember, it doesn't have to be a function to have domain and range. All relations, any set of ordered pairs, any set of domain and range is a relation. Special relations are functions if the domain doesn't repeat. So let's see. -1 goes to 8, 0 goes to 6, 1 goes to 6, and 2 goes to 7. Is that an example? Does that describe a function? Yes or no? Okay. Do any of these domain values ever go to 2 different values in the range? Do any of these in the domain column go to 2 different range values? No. So the domains never repeat. There's no repeating. If you actually wrote them as ordered pairs, -1 and an 8, 0, 6, 1, 6, 2, 7. You can see that all of the X's are unique. Okay. Now, you have to do number 9, but number 10 is very similar. On number 9, this is an entire one value in the domain. This is another value in the domain. What they should have done is they should have just gone NFC and then AFC, because it looks like there's 3 things there. Okay. Over here, Alabama has 9 electoral votes in 2010, 2012. Alaska, 3. Colorado, 9. Delaware, 3. Nebraska, 5. Is that an example of a function? If any of the domains go to 2 different range values. Who? Alabama has only 1 arrow going from it. Colorado, now remember, the range can happen more than once. So these 2 have exactly 1 answer. This 3 has 1 state and has a different state, but each state, the domains have exactly only 1 value of electoral votes. You can't have a state that has, oh, over here in that set of years, they've got 5 electoral votes and they also have 4 electoral votes. Which one is it? Okay, that's function.
So when they all equal like 1 answer, or
well, there's only 1 arrow coming from each of the domains. That's a function.
I just wanted to, make sure that that's
well. Again, look at the way we wrote it over here. For each of these X's, 1 at a time, there was only 1 answer. Or let's put it this way. we never had any of these ordered pairs where the X was the same. It never repeated. There wasn't two answers when I plugged in -1. There weren't two answers for the 0. None of the domains had two Y values. Let's just look at number 9. That function. No, because the NFC has 3 answers. And the AFC has 3 answers. Okay, this domain has 3 different answers. So you would have an ordered pair of NFC, and then the Giants, NFC, and then the Saints, NFC, and then the Seahawks. But look at the X's, they're all NFCs. If you're a function, the X's can't be the same. Okay. 10 and 13. 13, 13. In question 11 through 14, the top one says, determine whether the relation represents Y as a function of X. So number 13 is a picture of a relation. All those little, points, all those little, like a scatter plot, is a picture of a relation of ordered pairs. Is that picture a function? No. That's not a function. Because right here, we got 0, 1. But right here, this ordered pair is 1, 2. But down here, this is 1, 0. X is 1 at both of those points. That X value has 2 different Y's, not a function. This one right here, this X value is 2. This is 2, 3. Down here, this is 2, -1. The X's are the same. They're both 2s. X can't repeat, they're not a function. And same thing with the third one, or the fourth one. The quickest way to eyeball it is something called the vertical line test. Does it pass or fail the vertical line test? If you could make a vertical line through your picture, and the vertical line has 2 of those points on it, it fails the vertical line test, therefore not a function. So right here, there's only 1 point, that one, on the vertical line. So when I put my vertical line right here, that vertical line has 2 different points on it, which means it fails the vertical line test, not a function. This one, if I drag a vertical line from left to right, at any time, a vertical line is never going to intersect that scattering of points more than once. So number 14 is a function. And just so we're clear, you don't have to do number 14. I'm just using that as a comparison. 13, 14, 16. I'm doing 16 to show you 15. So, which sets of ordered pairs represent functions from A to set B? Set A to set B. Now, from set A to set B, that means A represents your domain. B would have to be your range. From A to B, that's one direction. A to B, A is the domain, B is the range. So A is A, or right here, A. Then we have a C, and then we have a C again, and then a B. The domains are A, B, C, that A, C, C, D. Is this set of ordered pairs an example of a function of these two sets? No, because the domain value of C is in two of them. And the domain value cannot have two different ones. When I plug in C, out comes 2, but over here, out comes 3. Make up your mind, which one are you? Are you a 2 or are you a 3? Okay. So no, not a function. Then you do B. Both this time, erase what you just thought about for part A. B is a brand new question. When you plug in A, we get a 1. When you plug in B, you get a 2. When you plug in C, you get a 3. Is that an example of a function from A to B? Yeah. None of the domain values ever repeat more than once. Or they never repeat. Okay, so that's a function. That's an example of a function from set A to set B. This is, yep. And then the last one, when we plug in 1, we get A. We plug in 0, we get A. Plug in 2, we get C. Plug in 3, we get B. Is that an example of a function of set A to set B? No. Now, it's a function, but it's not A to B. If it's A to B, the domain has to be the A, B, or C. Look at the domains over here. The X's are 1, 0, 2, and 3. The domains are coming from B, not from A. This is an example of a function from B to A. If you took something from this set as your domain value and paired it up with something over here and used this as your range, that would be a function from set B going the other way to set A. Not what they're describing. Not what they're describing. Okay? So that is not a function from A to B. We actually did something like 19, talked about it. Even looked at one. Determine whether the equation represents y as a function of x. Y as a function of x. So now, if you want to actually reference this in the textbook itself, so you can see where we're pulling this information from. Testing, this is example 2 from page 98. Basically where we left off last Thursday. Testing for functions represented algebraic. Determine whether the function represents y as a function of x. Okay. So 19. X squared plus y squared equals 4. So if y is a function of x, that means we're only going to get one y for every x that we plug in. So if we subtract x squared, we get y squared equals 4 minus x squared. You take the square root. Because you are solving for all the values of y with respect to this x, you would need to put plus and minus. Y is equal to plus or minus the square root of 4 minus x squared. You actually had to do a problem like this when we first were learning how to use the graphic calculator. We had to type in both halves of this equation so you could see the circle that it makes. So you get a y equals negative square root of 4 minus x squared. Y equals a positive square root of 4 minus x squared. So when you let x equals 0, y would equal negative square root 4 minus 0 squared. Y would equal negative square root of 4. Y equals negative 2. So when you plug in 0, you get negative 2. But you would also have to plug it into here because it's equal to plus and minus of it. Y is equal to positive square root 4 minus 0 squared. Y is equal to the square root of 4. Y equals positive 2. So when 0 goes in, you get two different y values, which means you're not a function. You don't need to do that last part. I'm just showing you why it's not. You can stop right here when you see, oh, y is two different things for every x you plug in, because there's a plus and minus. That's two different things. Okay? Not a function. Now here's why I chose to make sure I do 21. It's 21 right next door or below. Y equals square root of x squared minus 1. That's a function. That's a function. Now, wait a minute, they both have square roots. Yeah, they do. But did 19 start with a square root? No. To do number 19, you had to solve for y by itself. They want to know, is y a function of x? So you had to get y by itself. And when you did that, you took the square root of both sides, you ended up with plus and minus to define the y. In number 21, you are explicitly told, this is going to be an implied domain, by the way, but you're explicitly told that just y is just positive square root x squared minus 1. There's no plus and minus in front of it. So if I plug in 0, well, actually I can't because 0 squared minus 1. If I plug in 1, y equals the square root of 1 squared minus 1, y equals 1 minus 1, y equals square root of 0, y equals 0. So when you plug in 1, you get 0. If I plug in, well, this is not going to be a nice one because we got not going to come out to be a perfect square, but that's all right. If I plug in 2, y equals the square root of 2 squared minus 1, y equals the square root of 4 minus 1, y equals square root of 3. So when x is a 2, you get square root of 3. I don't get 2 answers when I plug in 2, I just get 1. That's a function. Because it was just given as one answer, but here you ended up with y equals plus and minus. Here you don't have the plus and minus. You see the difference? What did you start with? That's the difference. Here you started with x squared plus y squared. Here you didn't. Yes.
So for the first one, that one was not a function.
The first one is not a function.
And the second one was.
Second one is. So h of t. So function h with respect to the variable t is equal to t squared minus 2 times t. So find a, what is h of a 2 equal to? And then B, what is H of 1.5? And then H of X minus 4. Remember what I told you? Just substitute. Don't try to substitute and simplify. I'm going to go C back to A. So I'm just going to probably only get through C. When I replace T with an X minus 4, all the T's get replaced with X minus 4s. Just like it.
Okay.
So this T squared is now going to be parentheses X minus 4 squared. Minus 2 times T becomes minus 2 times X minus 4. Thank you. And over here, I wrote this down as X minus 4. So H of X minus 4, you're going to square this. So for the sake of time, this is X squared minus 8X plus 16. Because this would be X minus 4 times X minus 4. And then you distribute the negative 2. Negative 2 times X is minus 2X. Negative 2 times negative 4, that's a plus 8. And then combine your like terms. H of X minus 4 is looking for all your X squareds. That's the only X squared. X to the first, you have a negative 8X and negative 2X. That's negative 10X. And then a positive 16 and a positive 8 is a positive 24. All right, let me do the roll. And we'll pick up there. Now, the quiz. The quiz is going to be on 1.3 next Tuesday. So I'll tell you more about that next Thursday. Next Thursday. So Josh Aguilar.
Here.
And Jasmine and Charles. And Francisco Delmar. Here. And Louis. Radia. And Brian. Here. And Marcelino. And David. And Danielle is here. And Alyssa Rios. Here. And Alma. Here. And Ryan. And Kelsey. All right. If you need to see more of this, I'm happy to stick around, but if you don't, I will see you on Tuesday.